We start with Russia's submarine of tomorrow, the Laika-class, also called Husky, represents Russia's fifth-generation attack submarine, currently under development and scheduled for construction starting in 2027. If you're watching this in 2027, the Laika/Husky class should be in the water by now. Drop a comment and let us know if it actually is. In April 2025, President Putin announced plans to build 8 of these boats as a more cost-effective alternative to the expensive Yasen class. Here's what makes the Laika fascinating. This modular submarine is designed around flexibility with an estimated displacement of 11,340 tons, capable of hitting 35 knots submerged, faster than the Yasen's 31 knots. The modular design means different variants can be configured for different missions: cruise missile strikes, anti-submarine warfare, even potentially as a ballistic missile platform. The armament includes Caliber, Onyx, and the hypersonic Zircon missiles, with vertical launch systems carrying up to 16 missiles. The Laika is designed to dive to 600 meters and operate for 90 days continuously, with a crew of about 90. Unlike Western submarines with pump jet propulsion, the Laika uses a traditional screw propeller to reduce complexity and cost. The design reportedly features composite materials in the hull, silent torpedo tubes using water instead of compressed air, and an AI-powered integrated combat control system. If Russia can actually build these on schedule, they'll replace the aging Akula and Sierra classes starting in the 2030s. But given Russia's track record with ambitious submarine projects, we'll see if the Laika actually materializes on time. Khabarovsk, Project 09851, and Belgorod, Project 09852. Now we enter territory that's genuinely unsettling. These aren't traditional attack submarines. They're strategic weapons platforms designed specifically to carry the Poseidon nuclear torpedo, which Western analysts have dubbed a doomsday weapon. The Belgorod was commissioned in July 2022 and 184 meters long and displacing 30,000 tons submerged. It's one of the largest submarines ever built, longer than most ballistic missile submarines. Originally laid down in 1992 as an Oscar II cruise missile submarine, it sat 75% complete for years before being redesigned starting in 2012 for its new mission. The Belgorod can carry 6 Poseidon torpedoes, each measuring 24 meters long, weighing 60 tons, and capable of traveling over 10,000 kilometers at depths up to 1,000 meters. These nuclear-powered, nuclear-armed torpedoes are designed to destroy coastal infrastructure and create radioactive tsunamis. The Belgorod also serves as a mothership for deep-diving mini-submarines and underwater infrastructure deployment, operating under Russia's secretive Main Directorate Deep Sea Research. The Khabarovsk was launched in November 2025 and is expected to enter service by the end of 2026. Unlike the converted Belgorod, the Khabarovsk was designed from the ground up for the Poseidon mission. Based on a shortened Boré-class hull, it's smaller at around 135 meters long and 10,000 tons displacement, but optimized specifically for carrying 6 Poseidon torpedoes. Defense Minister Andrei Belosov described it as a heavy nuclear-powered missile cruiser, emphasizing its role in Arctic operations. Russia plans to build at least 4 Poseidon-capable submarines total, creating an entirely new pillar of maritime nuclear deterrence outside the traditional ballistic missile submarine force. These submarines represent Russia's answer to increasingly capable Western missile defenses, weapons that can't be intercepted because they travel underwater at extreme depths. Yasen M, Project 885M, and Yasen, Project 885. Now we're in the 4th generation, and this is where Russia's submarine capability gets genuinely impressive. The Yasen class represents the pinnacle of Russian submarine engineering, boats that Western navies quietly worry about. The original Yasen, lead boat Severodvinsk, took nearly 18 years to build, launching in 2010 and commissioning in 2014. The improved Yasen M variant cut construction time to about 8 years, while making the submarines shorter, quieter, and more efficient. According to U.S. Admiral James Fago, commander of Naval Forces Europe, these submarines are very quiet, which is the most important thing in submarine warfare. Some assessments suggest the Yasen M can maintain 20 knots while running silent, approaching American Seawolf-class stealth levels. These are true multi-role submarines, attack boats that also serve as crew cruise missile platforms. The Yasin carries up to 40 caliber cruise missiles, or 32 Onyx anti-ship missiles in vertical launch tubes, plus torpedoes. The newest boats, like Perm, launched in March 2025, are specifically designed to carry the hypersonic Zircon missile, traveling at Mach 6 to 8 with ranges over 1,000 kilometers. 5 have been commissioned so far, with more under construction. These submarines can dive to 600 meters, hit speeds around 31 knots, and operate with a crew of about 85. The Yasin-class combines Western-style spherical bow sonar arrays with Russian engineering philosophy, creating submarines that can hunt other submarines, attack surface ships, strike land targets, and lay mines. This is the submarine keeping NATO planners awake at night, a boat that finally gives Russia a genuine peer competitor to American Virginia-class submarines. Oscar II-class, Project 949A. The third generation begins with submarines designed for one specific terrifying mission: kill American aircraft carriers. The Oscar II is not subtle about its purpose, displacing nearly 20,000 tons submerged and stretching 154 meters long. These are among the largest attack submarines ever built. The Oscar II carries 24 P-700 Granite missiles, each weighing 7 tons, measuring 10 meters long, flying at supersonic speeds with a range of 550 kilometers. These missiles can carry either a 750-kilogram conventional warhead or a 500-kiloton nuclear warhead. The 24 missile tubes run along both sides of the hull in 2 rows of 12, angled at 40 degrees. The Soviet doctrine was brutal: coordinate multiple Oscar IIs, launch salvos of granites simultaneously to overwhelm carrier battle group defenses, and disappear before escorts can retaliate. The most famous Oscar II was the Kursk, which sank in August 2000 during naval exercises in the Barents Sea after a torpedo explosion, killing all 118 crew members. 6 Oscar IIs remain operational, with some being modernized to carry up to 72 modern caliber or Onyx missiles instead of the 24 Granites, dramatically increasing their firepower. These submarines proved that the Soviet Union could threaten American naval dominance without building their own massive carrier fleet. Oscar I-class, Project 949. Before the Oscar I came the Oscar I, the proof of concept. Only 2 were built between 1975 and 1982, serving as experimental platforms for the anti-carrier doctrine. The Oscar I carried the same 24 Granite missiles, but with less sophisticated targeting and electronics. These submarines validated the concept that cruise missile submarines could genuinely threaten carrier strike groups. Both Oscar I submarines were decommissioned in 1996 and scrapped in 2004, but they established the foundation for the feared Oscar II class and proved the carrier killer concept worked. Akula-class, Project 971. The Akula, ironically meaning shark in Russian, became the backbone of Russia's attack submarine fleet and represents a watershed moment, the first Soviet submarine that genuinely alarmed Western navies with its quietness. When Akulas started appearing in the late 1980s, Western analysts had a moment of shock because these submarines were quiet, shockingly quiet. The Akula uses a unique double-hull design, an inner pressure hull and outer hydrodynamic hull with rubber between them to dampen sound. The improved Akula II was assessed by U.S. intelligence as quieter than contemporary American submarines. Armed with torpedoes, anti-ship missiles, and cruise missiles, an Akula can dive to 600 meters and hit speeds exceeding 33 knots submerged. These submarines proved their stealth in dramatic fashion. In 2012, one reportedly operated in the Gulf of Mexico undetected for over a month, demonstrating their capability to penetrate American defensive screens. But the class has a dark chapter. In 2008, the NERPA suffered a catastrophic accident during sea trials when its fire suppression system accidentally activated, releasing Freon that killed 20 people through asphyxiation, the worst Russian naval accident since the Kursk. Despite this tragedy, several Akulas remain in active service. One has even been leased to India as INS Chakra, demonstrating the continuing value of these submarines decades after their introduction. Sierra II-class, Project 945A. The Sierra II represents what happens when you take experimental titanium submarine technology and make it practical. 4 were built, featuring titanium hulls that allow operations at depths around 520 meters, deeper than most NATO submarines. The titanium provides incredible strength, deep diving capability, and corrosion resistance, though at enormous cost. Unlike the temperamental Alpha, these submarines used proven, maintainable systems. They incorporated improved quieting technologies and automated systems, combining the benefits of exotic materials with reliability. Several remain in Russian service, having demonstrated that titanium submarines can be operationally viable when properly designed, rather than maintenance nightmares. Sierra 1 class, Project 945. Before the Sierra 2 came the Sierra 1, the first attempt to operationalize titanium hull technology beyond experimental prototypes. Two were built in the 1980s. These submarines proved that titanium submarines could be reliable workhorses rather than temperamental science projects. They validated the concept that would mature in the Sierra 2 design, showing that the deep-diving, corrosion-resistant benefits of titanium hulls could be achieved in practical, operational boats. Alpha class, Project 705. Now we enter submarines that seemed like science fiction. The Alpha class represents Soviet engineering at its most audacious and borderline insane. These were submarines that could outrun torpedoes. Imagine a submarine with a titanium hull diving to operational depths of 400 meters, possibly reaching 800 meters maximum, while hitting speeds over 41 knots submerged. Only 7 were built. The Alpha used lead-bismuth-cooled reactors, the same technology that failed so catastrophically in K-27, but refined and improved. The reactor was so compact, it enabled a crew of just 31 people, operating from a single automated control room. Here's the catch. The lead-bismuth reactor had to be kept above 125 degrees Celsius at all times. If it cooled and solidified, it could never be restarted, ever. This happened to the lead boat K-64 in 1972, forcing its early retirement. When they worked, Alphas were interceptors, stay in harbor, race out at blistering speed when threats appeared, attack, and escape by diving deeper than enemy torpedoes could follow. The titanium hull provided incredible strength while reducing magnetic signature, but it cost a fortune. Western navies were so alarmed that both the US and UK developed new high-speed torpedoes specifically to counter this class. All Alphas were decommissioned by 1996, but they proved capabilities that seemed impossible and influenced every subsequent Russian submarine design. Mike class, Project 685. The Mike class represents another Soviet experiment in pushing absolute limits. Only one was built, K-278 Komsomolets, and it achieved something no other combat submarine has matched. This vessel dove to 1,027 meters, over 3,300 feet, setting a depth record that still stands today. The titanium hull and advanced design made operations possible at depths where most submarines would implode like crushed cans. Tragically, Komsomolets was lost in a fire in April 1989 in the Norwegian Sea, taking 42 crew members with it. Despite its tragic end, the Mike class proved extreme depth operations were possible and provided invaluable data for future submarine designs, demonstrating the potential of pushing engineering boundaries even when the cost was catastrophic. Victor 3 class, Project 671 RTM. The second generation begins with a watershed moment, the Victor 3, the first Soviet submarine that genuinely worried Western navies with its acoustic stealth. Over 20 were built, incorporating rafted machinery, improved hull coatings, and advanced propeller designs that dramatically reduced noise. When Victor 3 started appearing in the 1980s, Western analysts noted a significant jump in quieting technology. This showed that Soviet designers had finally cracked the code on acoustic stealth, closing the gap with Western submarines. Armed with torpedoes and anti-ship missiles, these hunter-killers became the workhorse of the Soviet fleet through the 1980s and remained in service well into the 2000s. The Victor 3 proved the Soviets could build submarines that were genuinely difficult to detect, marking the end of unchallenged Western acoustic superiority. Victor 2 class, Project 671 RT. The Victor 2 served as the bridge between the original Victor and the successful Victor 3. 7 were built in the mid-1970s, featuring improved sensors and speed over the Victor 1. They were longer, accommodating better sonar systems and additional equipment. These submarines served as test beds for technologies that would mature in the Victor 3, Husky, representing steady but unglamorous progress in Soviet submarine capabilities. All have been retired, their lessons absorbed into more capable designs. Victor I class, Project 671. The Victor I represents the Soviet Union's first truly modern nuclear attack submarine. 16 were built starting in the late 1960s, and they showed the world that Soviet submarine builders could create genuinely capable hunter-killers. Unlike earlier designs that were noisy and problematic, the Victor I featured teardrop hulls for improved underwater speed and maneuverability, reaching around 30 knots submerged. Armed with torpedoes for anti-submarine and anti-surface warfare, they were still noisier than contemporary Western boats, but represented a massive leap forward from the November class. The Victor I established design principles that would carry through the entire Victor line and influence all subsequent Soviet attack submarines, proving the Soviets had finally mastered the basics of nuclear submarine construction. Charlie II, Project 670M. The Charlie II refined the original Charlie I design. 6 were built between 1973 and 1980, featuring improved electronics, better missiles, and enhanced quieting. Carrying 8 cruise missiles and torpedoes, the Charlie II could launch while submerged, a significant tactical advantage over earlier designs that had to surface. While smaller than the massive Oscar class, the Charlies provided a more affordable way to field cruise missile capabilities. All have been retired, but they proved the SSGN concept that would reach its peak with the Oscar class, demonstrating that submarines could be effective cruise missile platforms without massive size. Charlie I class, Project 670I. The Charlie I represents the first Soviet nuclear-powered cruise missile submarine with submerged launch capability. 11 were built between 1967 and 1973. These boats carried 8 anti-ship cruise missiles in individual tubes angled upward in the bow. Unlike earlier cruise missile submarines that had to surface to launch, making them vulnerable to counterattack, the Charlie could fire while submerged. The trade-off was reduced speed and increased noise compared to pure attack submarines, but the Charlie I proved the concept worked and led directly to improved cruise missile designs. Papa class, Project 661. If the Alpha was ambitious, the Papa class was pure experimental madness that pushed physics to its limits. Only one was built, K222, and it still holds a record that stands today. This single submarine achieved 44.7 knots submerged. That's over 50 miles per hour underwater, making it the fastest submarine in history, period. The Papa used a titanium hull and experimental cruise missile systems, serving as a testbed for technologies that would later appear in the Oscar class. It operated from 1969 into the 1980s, proving Soviet engineers could push submarines to performance levels that Western navies didn't think possible. The extreme cost and complexity meant only one was built, but the lessons learned about high-speed underwater operations and missile systems influenced every subsequent cruise missile submarine. Yankee Notch, Project 667AT. The Yankee Notch represents Soviet ingenuity in response to arms control treaties. When SALT I limited ballistic missile submarines, the Soviets converted 4 Yankee-class ballistic missile submarines into cruise missile attack boats between 1982 and 1991. The missile compartment was replaced with a distinctive notch-waisted center section, featuring 8 533mm torpedo tubes angled to fire cruise missiles, up to 40 SS-21 Granite missiles total. The forward torpedo tubes were retained, and some reports suggest these boats could fire massive 650mm Type 65 torpedoes. The emphasis on cruise missile carriage suggested a tactical role or as second strike nuclear submarines. The configuration was a combination of SALT treaty compliance and typical Soviet unwillingness to completely discard military hardware. These conversions showed the Soviets could adapt existing hulls to new missions, extending the operational life of obsolete ballistic missile submarines. Yankee Sidecar, Project 667M, K420. The Yankee Sidecar was another single-boat conversion that appeared in 1983, but this one was even more unusual. K420 K-420 was converted to carry 12 SSNX-24 meteorite nuclear-tipped cruise missiles. The SSNX-24 was an experimental missile with supersonic flight and twin nuclear warheads meant as a tri-service strategic weapon. The boat was lengthened to 153 meters and displaced 13,650 tons to accommodate these massive missiles. But the missile program was canceled, and K-420 became a weapons system without a weapon, an expensive submarine with no purpose. It demonstrated the risks of building platforms around experimental weapons before the weapons themselves are proven. The Yankee sidecar served until the 1990s, but never fulfilled its intended role. Before we dive into the very first generation of nuclear boats, we have to mention a unique evolutionary dead end, Project 651E. The original Juliett-class were diesel-electric subs, but in a strange experiment, the Soviets fitted one, the K-68, with a tiny auxiliary nuclear reactor called the VAU-6. It was designed to give a diesel sub the endurance of a nuclear one without the massive cost, and it remains a unique, forgotten hybrid in Soviet history. Echo-2-class, Project 675. The first generation represents Cold War submarine design at its most aggressive and crude. The Echo-2 was built for one purpose: overwhelm American carrier defenses through sheer numbers of missiles. 29 were built between 1962 and 1968, each carrying 8 cruise missiles. The catch? They had to surface to launch their missiles, making them incredibly vulnerable to counterattack. The doctrine called for coordinated strikes by multiple Echo-2s, launching enough missiles simultaneously to saturate carrier battle group defenses. They were noisy by any standard, but packed devastating firepower. Many were later converted to attack submarines when better cruise missile boats became available. The Echo-2 represented the Soviet Navy's first serious attempt at creating a submarine-based anti-carrier capability, proving the concept before the technology was truly ready. Echo-1 class, Project 659. Before the Echo-2 came the Echo-1, 5 submarines built between 1960 and 1963, the Soviet Union's first nuclear-powered cruise missile submarines. Carrying 6 cruise missiles in distinctive raised tubes running along the top of the hull, they had to surface to launch, presenting obvious tactical problems. These submarines served primarily as experimental platforms, proving that nuclear-powered boats could carry and launch heavy anti-ship missiles. They were quickly superseded by the improved Echo-2 design, with most eventually converted to other roles or retired early. The Echo-1 established the cruise missile submarine concept, even if the execution was flawed. Project 645, K-27, Liquid Metal Reactor Attack Sub. Project 645 produced only one submarine, K-27, and it was a disaster that taught crucial lessons. This was a modified November-class submarine equipped with 2 experimental VT-1 liquid metal-cooled reactors using lead-bismuth coolant. Launched in 1962 and commissioned in 1963, K-27 was designed to test the reactor technology that would later be refined for the Alpha class. The reactors were troublesome from the start, but K-27 managed 5 years of operations, including becoming the first Russian nuclear submarine to remain submerged for 50 consecutive days. Then came catastrophe. On May 24, 1968, during full power trials in the Barents Sea, the port reactor suddenly lost power, dropping from 87% to 7%, and began venting massive amounts of gamma radiation and radioactive gas. About 1/5 of the reactor core had experienced inadequate cooling, causing hotspots that ruptured and released nuclear fuel into the coolant system. 9 crew members died from acute radiation poisoning, and 83 were injured, with 40 suffering acute radiation sickness. The crew didn't fully understand the danger until it was too late. Some had dinner in the contaminated compartments before radiation alarms were finally sounded. K-27 limped back to port on the starboard reactor and was laid up at Gromyka Bay. Plans to replace the reactor compartment were deemed too expensive. In 1982, the reactor compartment was filled with solidifying mixture, and K-27 was scuttled in shallow water in the Kara Sea at just 33 meters depth, contrary to international requirements for scuttling nuclear vessels at depths exceeding 3,000 meters. K-27 lies there today, a nuclear time bomb, according to some experts, with concerns about potential uncontrolled reactions as the hull corrodes. Despite the tragedy, lessons from Project 645 were applied to the Alpha class, which used refined versions of the same liquid metal reactor technology. November class, Project 627. We end where it all began. The November class, the Soviet Union's first nuclear submarines, and they were dangerous, problematic disasters that nonetheless started everything. 13 were built between 1958 and 1964, beginning with K3 Leninsky Komsomol. These boats were revolutionary for the Soviet Navy, but deeply, dangerously flawed. They were incredibly noisy, leaked radiation, and suffered from numerous mechanical problems. The accident rate was shocking. K8 sank in the Bay of Biscay in 1970 after a fire, killing 52 crew members. K159 sank while being towed for scrapping in 2003, taking 9 crew members down with it. K3 suffered a catastrophic fire in 1967 in the Mediterranean that killed 39 sailors. Despite their problems, the November class represented a crucial technological leap. The Soviets learned from every failure, every accident, every design flaw. The knowledge gained from operating these troublesome boats informed every subsequent Soviet and Russian submarine design. They were proof that the Soviet Union could build nuclear submarines, even if they couldn't yet build them well. The November class didn't just start the Soviet nuclear submarine program, it taught Soviet engineers the brutal, often deadly lessons needed to eventually create submarines that could genuinely challenge Western naval supremacy. Without the November-class failures, there would be no Akula, no Yasin, no submarines capable of threatening NATO dominance. The November class was the painful, costly foundation upon which everything else was built.